Hi everyone, welcome to Learning Math with VK. Today we explore lesson 8 in algebra, linear inequalities and applications. Number 1, inequalities. An inequality is a relation which make non-equal comparison between two expressions. Well, we have 4 inequalities. X less than 1. You can use number 2, 3, 4. I used 1 for simplicity. Meaning of the notation is less than. In the graph, there's the number line. 1 is somewhere here. For less than, we used an open circle and the arrow go to the left side. The corresponding interval notation is negative infinity to 1. We do not include 1, so we used parentheses. Second inequality, x less than or equal 1, meaning it's less than or equal to. It can also be at most. The graph of this one, and because we have equal to 1, we use a solid circle to include 1. The arrow go to the left side. Negative infinity to 1. To include 1, we use the bracket instead of parentheses. Another inequality is x more than 1. More than. Sometimes people say greater than. In the graph, 1 open circle, the arrow go to the right. So that means we go from 1 to infinity. Last inequality, x greater than or equal 1, greater than or equal to. It can also mean at least. Here come the graph. 1, and because we include 1, we used a solid circle. The arrow goes to the right. Bracket on 1 to infinity. Inequality have the same property as equation. However, there's one that we have to be a little careful on. And that is when we divide or multiply by a negative number. Let's take a look at that one. So we know x less than 1 tell us that we have all the value, all the number less than 1, meaning that 1, 0, -1, -2, and the arrow goes to the left side. When we multiply or divide by -1, we get -x. Okay, so -x, what is going on here with the -x? Is it still less than 1? Let's take a look. We have a 0, 1, -1, -2, 2. -x tells us that we have to negate the answer. Negative of 1 is -1. 0 is already there. Negative of negative 1 is 1, negative 2 is 2, meaning that we go from negative 1, including 0, 1, 2. The solution must go the opposite direction from negative 1. What this means is that when we multiply by negative 1, we must switch the inequality. X is greater than negative 1. When multiply or divide by a negative number. Okay. That is the very important notes. I'm gonna type it up. Remember to switch inequality when multiply or divide by a negative number. Let's move on to the second part. Second part is linear inequalities. A linear inequality is an inequality in which the power or exponent of x is 1. It's very useful in getting the domain of a function that we're gonna study later on. Here comes some example. Solve for x and write answer in interval notation. The first example is 2x minus 1 greater than 0. The same way as we solve for x in an equation. Isolate x on one side of the equation. Plus 1 on both sides. So I have 2x greater than 1. And then divide both sides by 2. X greater than 1 over 2. Greater than, according to the table, we use the notation, interval notation from 1 over 2 to infinity. 1 over 2 to infinity. Second example, 4x plus 7 greater than or equal to negative 13. Minus 7 on both sides. 4x greater than or equal to negative 20. And then we divide both sides by 4. X is greater than or equal to negative 5. We go from negative 5 to infinity, including negative 5. Another example. Let's say negative x plus 1 greater than or equal to 0. Yes. Similarly, minus 1 on both sides. Minus x greater than or equal to negative 1. And then we divide both sides by negative 1. Or you can multiply by negative 1, up to you. Negative 1, negative 1. Oh, divide by a negative number. Remember, we switch the inequality. X less than or equal to 1. X less than or equal to 1, meaning that we got to go from negative infinity to 1, including 1. Negative infinity to 1, and we include the number 1. The notation, the interval notation, are very useful in writing out the domain of a function, range of a function, increasing, decreasing interval, and then many cool stuff that we're gonna study later on. Okay, inequality has the application in real life Right? Some very useful, such as application in housing. A couple wants to rent an apartment. To qualify for rent, their monthly income must be at least 3 times the rent price if they make 7,500 per month. What is the maximum rent price they are qualified for? Okay. To do this one, I'm gonna look at this and we're gonna copy and paste it. This statement right here. This is what it means for them to qualify for rent. Their monthly income must be at least 3 times the rent price. Monthly income, well, that is 7,500. Must be at least greater or equal to 3 times the rent price. 3 rent price, we don't know. So we can let the rent price be X, so 3X. And then from here, we just have to solve for X. Pretty cool, huh? Divide both sides by 3. And we have 2,500. We're going to go to X or X less than or equal to 2,500. This notation is better. What this means is that the maximum rent price they can qualify for is 2,500. Application in business. A multi-store owner paid $35,000 per month in fixed cost to operate the store. Each cup of milk tea costs $2 to make, and it is sold for $5.50. Given the fact that profit is the difference between revenue and cost, how many cups of milk tea should the store make and sell each month to generate at least $20,000 in profit? That's good money. Let's take a look. We know profit is, that is what we want here. We want to generate at least $20,000 in profit, meaning that profit is greater than or equal to 20,000. Profit is revenue minus cost, greater than or equal to 20,000. Revenue is price times quantity. Cost is fixed cost plus variable cost. Okay. Price per cup is $5.50. Quantity, well, we don't know the number of cups, so the quantity is going to be X. The fixed cost is 35,000. Variable cost, well, it costs $2 to make each cup of milk tea, so that would be 2X. Greater than or equal to 20,000. Distribute a negative 1, then we get negative 35,000 minus 2X, 5.50X, very good, 20,000. Combine like term, 5.50 minus 2 is 3.50. X minus 35,000. We're going to 20,000. Add the 35,000 to one side. 3.50x greater than or equal to 55,000. And then we just have to divide both sides by 3.50. And that would get us x to be greater than or equal to 157.14. Well, round off to be 157.14. Thank you for watching. I hope you find the content useful. Please like and subscribe to help the channel grow. I'll see you in the next video.